Hello, and thank you for viewing our math review for the TEAS test brought to you by the Daytona State College Academic Support Center. In this presentation, we will take a look at what types of math problems you can expect on the TEAS test and discuss strategies to help you get through them in a time-efficient manner. We hope you find this presentation helpful. The TEAS version 7 math subtest will consist of 34 questions over 57 minutes. This will give you approximately 100 seconds per question. Problems will be spread out over two broad topics, numbers and algebra and measurements and data. These topics will include, but are not limited to, arithmetic using the order of operations, working with fractions, decimal, and percentages, unit conversions, both imperial and metric, algebra concepts such as solving linear equations, simplifying expressions, and linear modeling, applications of geometry involving two-dimensional and three-dimensional shapes, and reading and interpreting graphs. Please note that any of these topics may be presented as a word problem. In this presentation, we will be focusing on advice and techniques for getting through each problem as quickly as possible. ATI will also provide a four-function calculator on each problem of the math portion of the test, and we will utilize that whenever we are able to. You will need to be able to convert between fractions, decimals, and percentages. All fractions are division, so you can utilize your calculator to get a decimal out of them just by taking the numerator divided by the denominator. In order to convert from a decimal to a percentage, just move the decimal place two places to the right. So that 0.04 would be 4%. In order to convert from a percentage to a decimal, you will do the opposite and move the decimal place two places to the left. So 40% would be 0.40. The quick way to make comparisons is between decimals and percentages first, because it's just moving the decimal place. So we can see that 0.04 is 4%, which is not 40%, so A is not correct. 0.375 is 37.5%, so B would not be correct. 0.44 is 44%, so we'll keep our eye on C. 1.25 is 125%, which is not the same as 12.5%. Everything has been eliminated except for C. So we can quickly get to answer C without ever having to convert a fraction in the case of this problem. Using our calculator, take 9 divided by 8. This will yield 1.125. Moving the decimal two places to the right will give us 112.5%. In order to add or subtract fractions, we need a lowest common denominator. Another way to think about the lowest common denominator is it will be the smallest number that is divisible by each denominator in our expression. In the case of 2, 3, and 5, 30 is divisible by both 2, 3, and also 5. We are going to scale each one of our fractions up to that lowest common denominator by multiplying the denominator portion by the number we need to get it to our LCD of 30, 15 in the case of 1/2 here. And we also need to multiply the numerator by that same value so that we don't change the value. It's 15 over 15 is equivalent to 1 and does not change the value of 1/2. Once we have every fraction sharing a common denominator, we will proceed to add the numerators only. When we multiply fractions, we are going to multiply numerator to numerator and denominator to denominator. When we are dividing fractions, we are going to multiply by the reciprocal of the divisor. What this means is that when I am dividing two fractions, such as 7/8 and 5/16, I am going to change the division to multiplication and flip the dividing fraction. This is going to give me 7/8 multiplied by 16/5 instead of 7/8 divided by 5/16. Once we have a series of multiplication with multiple fractions, any common factors in the numerators and denominators can cancel out. So for instance, 7/8 has a 7 in the numerator, while 30/49 has 7 times 7 in the denominator. One of those 7s in 49 can cancel with one of the 7s and 7/8 here. Once we cancel all common factors top and bottom, we will proceed to just multiply what's left in either the numerator or the denominator. 2 times 6 is going to give us 12. Everything canceled but a single 7 in the denominator, so we're left with 12 sevens for our answer for this problem. In order to simplify this expression, you need to know the order of operations. Often referred to as PEMDAS, you may have heard the mnemonic, "Please excuse my dear Aunt Sally." The order of operations consists of 4 steps. The first step being parentheses, anything that's contained in any sort of grouping symbol, such as parentheses, brackets, absolute value bars, or under a square root. We will simplify those first. The second step is exponents. We are going to handle any exponents before any other operation. The third step is multiplication and division, whichever comes first, from left to right. And the last step is addition and subtraction. To simplify this, first we must look into our parentheses. In our parentheses, the order of operations exists as well, so we need to handle our exponents before we handle our subtraction. 2 cubed is equal to 8. Our next step, simplifying parentheses, 2 minus 8 will give us -6. After that, we're looking for multiplication and division, whichever comes first, left to right. So our 18 divided by 9 will simplify to 2. Then we'll do more multiplication. 2 times 2 is 4, and more multiplication. With the 4 having a negative in front of it, we're going to multiply by the -6 to get -24, and then 4 minus negative, that double negative will give us positive, giving us our last addition and our solution. When organizing a set of numbers from least to greatest or greatest to least, the easiest way to solve these is to find the smallest or most negative number and the largest number first. In this set of numbers, we can see that -0.55 would be the most negative or smallest number, and 5 would be our largest number. 2 of our solutions will have 5 at the end, but only one of them will have -0.55 at the beginning. We can quickly eliminate incorrect options and get to the correct answer very quickly utilizing that technique. When organizing this set of numbers, we still want to identify our smallest or most negative number and our largest number. Looking at 41 divided by 29, we can tell pretty quickly that that is less than 2, as well as the square root of 2. That must be less than 2. And 1.41 is definitely less than 2. So although these are very close and it's difficult to tell which is the smallest, we can rapidly tell that 2 would be our largest value. So we're going to look for any option that has 2 as our largest number, which in the case of this problem is only A. so A must be the correct answer. Sometimes you will be asked to solve a question and replicate the steps of a solution that somebody else has come up with. I wouldn't recommend trying to make it match step by step, but instead look at the last step of each solution and solve the expression and aim for that last step. Only one option will solve for the correct answer. They won't trick you that badly. In the case of this problem, I would choose to combine my like terms first from the original expression. So 5x minus 8x will give me negative 3x. Then I want to move my variables to one side. It doesn't matter which, I'm just going to make a choice. In this case, I want to move the variables to the right. So I will add 7x to the left-hand side and add 7x to the right-hand side. On the left, negative 7x and positive 7x will cancel out. After that, my variables are consolidated into a single term on one side. I want to move the numbers or constant values to the other side. In this case, I will subtract 6 to get this positive 6 away from the positive 4x, and I will subtract 6 on this side as well. From here, I could divide by 4 and get an answer of x equals 1/2, which would correspond to answer C. But since I can see that 2 equals 4x is the same as 4x is equal to 2, I will stop right here and move on to the next problem. Some questions will be a little more straightforward than what they're asking you. In the case of this linear equation, we're just asked to find the valid solution. In order to do this, we want to move our variable terms to one side and our constant terms to the other. Then we will divide by the coefficient and get a value for our variable. I chose to subtract 9x and move my variables to the right-hand side. That left me with 5x on the right and no x's on the left. Now I need to move this constant value away from my variable term. In order to do that, I will subtract it. Now I have negative 10 is equal to 5x. My last step will be to divide by the coefficient on my variable term. Dividing by 5 gives me a value of negative 2 is equal to the x, or x is equal to negative 2. It doesn't matter which side of the equation these terms are on. Solving a linear equation that involves a fraction just requires us to divide by a fraction when we're dividing our coefficient off. In the case of 3x divided by 4, notice that that is the same thing as 3/4 multiplied by x. So our coefficient on x is 3/4, and therefore we will have to divide 3/4 off of that x. As when we're solving other linear equations, we want to begin by isolating our variable term. In this case, we'll move this negative 7 by adding 7 to both sides and canceling it out on the left. That is going to give us 3x over 4 is equal to 12. So we will need to divide the 3/4 off of x. In order to do that, we will multiply by the reciprocal. Notice that when I multiply 4/3 across 3/4, the 4's cancel out top and bottom, and the 3's cancel out top and bottom, leaving me with only x. When multiplying 12 by 4/3, I like to do the division part first. 12 divided by 3 is 4, and 4 times 4 is 16. Many of the questions that you will be asked will be formatted as word problems. It is important to be able to pick out exactly what they're asking from a word problem. So let's read through this and see if we can figure it out. A civil engineer is designing a bridge and determines that it will be 3,245 feet in length. If we take the average car length to be 14 feet 9 inches, then how many cars could fit in a single file line on the bridge? So we have a measurement of a bridge that is 3,245 feet, and we have a measurement for a car that is 14 feet and 9 inches. How many could fit sounds a lot like division. How many of these cars will fit on this bridge end to end? We do seem to have a problem in that feet of the bridge will be divided by feet and inches with the car, and those are not compatible units, so we were going to need to change 14 feet 9 inches into exclusively feet. In order to do this, we have to understand that 1 foot is equal to 12 inches. Many conversion factors you will be expected to know, and they will not be given to you, both imperial and metric units. 9 inches is the equivalent of 3/4 of a foot, or 0.75 feet. Therefore, 14 feet 9 inches is the same as 14.75 feet. Once we have compatible units, we can divide, and you will see that feet will cancel feet, top and bottom, with the division. 3,245 divided by 14.75 will equal 220. Therefore, 220 cars will fit on that bridge end to end. A 747 jumbo jet is currently traveling from Los Angeles to New York City, a total distance of 2,451 miles. The jet has been in the air for 3 hours at a speed of 570 miles per hour. How many miles does the plane have left to travel? Well, we're given a total distance of 2,451 miles and some information that we've been traveling 570 miles per hour for 3 hours straight exactly. So we must figure out our total distance and subtract the distance we've already covered. Remembering that distance is equal to rate times time, we can figure out that we have been traveling 570 miles per hour for 3 hours, or a total of 1,710 miles. 2,451 miles minus 1,710 miles is equal to 741 miles. A student is price shopping for a textbook on various websites selling the book. Website A has the book listed for $120, with a 10% discount for first-time purchasers. Website B has the book listed for a flat cost of $110. Website C has the book listed for $150, but is currently having a liquidation sale where all books are $40 off the list price. Website D is selling the book for $100, but requires a membership fee of $5, a purchasing fee of $4, and a publisher fee of $3. Which website provides the student the best deal on the book? A question like this, you're going to want to calculate the total cost for each one of these websites, and then make a quick comparison for whichever one is the cheapest. There are no real shortcuts to eliminate any of our calculations, so our goal is to just do them in an organized fashion and as quickly as possible. We can see that in option A, 120 times 0.9, which is 90% or 10% off of a value, is equal to 108, while B, C, and D are all more than that. Therefore, the correct answer is option A. Another option for figuring out 10% off would be to take 10% of 120 and then subtract it from 120. But I think taking 10% off of 100% and multiplying is a faster option. A recipe for cookies uses 6 ounces of packed brown sugar and makes a total of 48 cookies. In the pantry is a bag of brown sugar that weighs 1 pound. If all other ingredients in the recipe are supplied, how many cookies can be made? Assume no partial batches. Some word problems will test your reading comprehension. In the case of this one, assume no partial batches is important to our calculations. That means that we must make groups of 48 cookies using 6 ounces of packed brown sugar, and we're not able to make any sort of partial batches. So the answer must be a multiple of 48. We also need to know that 1 pound is equivalent to 16 ounces. Notice that 6 ounces goes into 16 ounces 2.67 times. So we would be able to make 2.67 batches of these cookies. Since we are not allowed to use partial batches, we can only make 2 full batches, and we will have some leftover sugar. 2 full batches will yield 96 cookies. A bag contains 210 red and green marbles. If there are 135 red marbles, what is the ratio of green marbles to total marbles in the bag? When you hear the word ratio, that just means fraction. Our ratio of green to total will be green in the numerator and the total amount in the denominator. Since we know that there are a total of 210 marbles and 135 red marbles, then the green marbles must be what's left. 210 minus 135 gives us 75 green marbles. The ratio of green to total would be 75 green marbles out of the 210 total. The answer will never be an unsimplified fraction, so always simplify your fractions. In this case, 75 and 210 are both divisible by 15, and that will simplify down to 5 over 14. 5 green marbles for every 14 total marbles. A mother gives her child a $20 bill and a grocery list. She says anything left over can be used for buying candy. The grocery list has the following items on it: milk for $2, bread for $3.50, soup for $1, and cabbage for $5. If the child spends the remaining money on chocolate bars, which cost $1.50 each, what is the maximum number of bars that the child can purchase? Assume sales tax is included in prices. So, once we take away all of our purchases from the $20 bill, what's left, and then how many times can $1.50 go into it? After buying our milk, bread, soup, and cabbage, we will have a total of $8.50 left. Dividing $8.50 by $1.50 will give us 5.67. In the context of the problem, we are buying whole candy bars. And most stores won't allow us to buy 0.67 of a candy bar, so we must assume that we can only buy 5 full candy bars and have a little bit of change left over. An elevator has a capacity of 2,000 pounds. A moving company is transporting an 85-inch, 120-pound television, as well as a variable amount of desktop computers weighing 30 pounds each, using the elevator. Which of the following algebraic sentences represents the limit of desktop computers that can be transported? Looking through this, we see that the elevator has a capacity of 2,000 pounds. That means that 0 up to and including 2,000 pounds is an acceptable amount of weight, but once we exceed 2,000 pounds, then we would be over capacity and risking danger. That must mean that the value must be less than or equal to 2,000 pounds. A moving company is transporting an 85-inch, 120-pound television. Well, 85 inches doesn't mean anything to us in the context of this problem, but 120 pounds does. Since there is only one of these televisions, that must be off by itself. So I'm looking for something that's less than or equal to 2,000 pounds and has a singular 120-pound item. We're also carrying a variable amount of desktop computers, weighing 30 pounds each. So we're going to have an unknown quantity of 30-pound computers. So with our capacity being less than or equal to 2,000 pounds, a TV that's 120 pounds by itself, and an unknown quantity of 30-pound computers, we can model it as such. The computers, the number of computers, plus the TV by itself must be less than or equal to 2,000 pounds. Since each computer is 30 pounds, the number of computers can be represented by a variable, such as C. In this case, 30 pounds per computer plus the 120-pound television must be less than or equal to 2,000 pounds. The table below includes precipitation data for the previous week. Which of the following statements about the measurements are correct? Well, looking at our set of data here, we're asked about mean, median, and mode. So let's talk about those ideas. The mean is the arithmetic average, and that's where you take every value, add them all together, and then divide that by the number of values that you added together. The mode is going to be any values that repeat themselves. The one that repeats the most is your mode. And the median will be your average, where you take an ordered set of values from least to greatest and seek the one immediately in the middle. If there's an even number, you will take the average of the two that land in the middle. Looking at our mean, we get a value of 0.043 by adding all of our values and dividing by the number of values. Our mode is 0.03. That is usually one of the easier ones to identify because it's just the one that repeats in this case. The median, once we organize our set of values, is the one in the middle. In this case, it's 0.03. For us, the mode and the median are the same. Only one of our options will be true. Which of the following statements shows a negative correlation? A correlation occurs when two things will numerically affect each other. A positive correlation will occur when, as one thing increases in value, another thing increases in value as well. A negative correlation will be as one thing increases in value, another thing will decrease in value. Let's look at our options. The cumulative amount of power used by the city over the course of a month, that would be a positive correlation. As the month progresses, the amount of power used by the city would increase. The number of pizza slices left in the box over time until they have all been eaten. This is a negative correlation, and I'm assuming the correct answer. As time progresses, we eat the pizza, it is decreasing until it is gone. A person's height compared to the color of their shirt, these would be two unrelated things and would have zero correlation whatsoever. The number of births every hour at the local hospital would also not have a correlation, as the amount of births per hour would be variable and unpredictable. Trapezoid has bases of lengths 3 feet and 13 feet. If the total area of the trapezoid is 24 square feet, what is the height in feet? For all two-dimensional geometric formulas for shapes, such as trapezoids, triangles, circles, rectangles, etc., you will be expected to know these formulas and be able to implement them. The area of a trapezoid is 1/2 times base 1 plus base 2, and then multiplied by the height of the trapezoid, or A equals 1/2 B1 plus B2 quantity multiplied by H. Since we know the area and the two bases, let's plug those into the formula and solve that formula for the height. Notice that 24 is equal to 8h. Dividing both sides by 8 gives us a height of 3. NASA launched the Tracking and Data Relay Satellite last year. The satellite orbits 22,300 miles above Earth. If we assume that 1 kilometer is equal to 0.6214 miles, what is the orbital distance in kilometer rounded to the nearest unit? This appears to be a basic conversion problem where we need to convert a quantity in miles to a quantity in kilometers. Since we know that 1 kilometer is equal to 0.6214 miles, we know that any ratio of those two quantities, since they're equivalent, would be equal to 1 and wouldn't change a value but would only change a unit. Since we're going from miles to kilometers, we want miles on opposite sides of the fraction bar so that miles will cancel out. In this case, 22,300 miles multiplied by 1 kilometer per 0.6214 miles is equal to 35,886.70743 miles. Since we were asked to round to the nearest unit, that means we need to round this to the whole number, and that 0.7 will bump 6 up to 7. A student has 2 jobs while also going to school. The first job is a work-study position, which pays $8.05 per hour. The second job is driving for Uber, making $11.50 per hour. If the student has 20 hours of work-study a week and managed to make $356.50 this week, how many hours of Uber driving did they do? Well, we can split this into our work-study money plus our Uber money is going to be equal to $356.50. We know exactly how much we made from work-study, and that's just $8.05 per hour multiplied by our 20 hours for a total of $161. Uber, we don't know how many hours we worked, but we do know our hourly rate. So we can plug in the information that we do know and make an equation out of this. We know our $161 from work study plus $11.50 multiplied by some unknown amount of hours from Uber must generate $356.50. Isolating our variable term of 1150x by subtracting 161 from both sides will give us 1150x is equal to 195.50. Dividing both sides by 1150 gives us x is equal to 17. So we worked 17 hours for Uber that week. At a local parking lot, there are a total of 110 parking spaces. There are 5 accessible parking spaces at the front of the lot in order to meet the requirements of the Americans with Disabilities Act. What is the percentage of spaces that are not accessible? Round your answer to the nearest percent. A percentage in this case is just going to be a ratio of the non-accessible spaces to the total amount of spaces, and then multiplied by 100% to turn it into a percentage. We know 5 of our spaces are accessible, so 105 of them are not. 105 out of 110 multiplied by 100% is going to give us 95.4545%. Rounding this to the nearest percent, the 4 will not affect the 5, so we will just drop our decimal portion and call that 95%. Tickets for a Jacksonville Jaguars football game cost $28, and the ticket price for a Tampa Bay Lightning hockey game costs $40. If X tickets are purchased for the football game and Y tickets are purchased for the hockey game, which of the following expressions represents the total cost of purchasing the tickets? Well, if we're buying X amount of tickets for the football game, and the football game costs 28 each, then the total amount for those would be 28 times X number of tickets. And if Y amount of tickets are purchased for the hockey game, and they're $40 each, then the total amount for hockey tickets would be $40 each, multiplied by Y amount of tickets. A room has a length of 10 feet 9 inches, a width of 8 feet 6 inches, and a height of 12 feet 3 inches. If we wish to paint the entire room, and the cost of paint is $0.85 per square foot, what is the total cost of paint needed to paint the room? Do not figure in windows, doors, or floor. Round your answer to the nearest cent. So in a question like this, we're going to need to figure out square footage. So we're going to need to change all of our measurements into just feet. Once we have a total square footage, then we're going to need to convert that into the cost per square foot. I like to have a visual aid when I'm working on any problems of this type. Notice in this problem, we're tasked with painting 4 of these walls and the ceiling. Notice that 2 of our walls, the ones on the sides, are going to have an area of width times height. The other 2 walls, forward and backwards, are going to have an area of length times height, and then the ceiling is going to have an area of length times width. We are given 3 measurements that have 3 inches, 6 inches, and 9 inches, which is conveniently quarter, 2 quarters, and 3 quarters of a foot, respectively. So we can convert our length to 10.75 feet, our width to 8.5 feet, and our height to 12.25 feet. Now, using our diagram, we know that our total area is going to be 2 of our walls that are length times height, plus 2 of our walls that are width times height, plus the ceiling, which is length times width. Plugging in all of our values gives us a total area of 563 square feet. Notice that 563 is one of our options, but it's not the correct option. We still need to figure out the cost per square foot for all of this area. The cost to paint is $0.85 per square foot, so we can use the conversion factor, $0.85 per 1 square foot, and multiply it across our 563 square feet. Notice that square feet cancels out and leaves us with $478.55. The graph below represents how much light is absorbed by a solution at various concentrations. When we're looking at this graph, the horizontal axis is concentration and the vertical axis is absorbance. Notice that as concentration is increasing, absorbance is also increasing. Also notice that all of our data points seem to be on or very, very close to a line. So it seems like these have a linear relationship and a positive correlation. The world's largest ice cream cone has a height of 3.08 meters and a diameter of 50 centimeters. The volume of a cone is given by the formula V equals 1/3 pi r squared h, where r is the radius and h is the height. Which of the following is the volume of the ice cream cone in cubic meters? Use 3.14 as an approximation for pi and round the answers to the nearest tenth. Well, all of our options are given in cubic meters, but one of our measurements is given as a diameter and in centimeters. Our formula calls for a radius, and all of our values must be in meters for it to produce cubic meters. So we're going to need to take diameter, turn it into a radius, and then turn that measure in centimeters to meters. Taking the diameter of 50 centimeters, cut it in half to get the radius. That's going to give us 50 centimeters divided by 2, which is 25 centimeters. Since we know 1 meter contains 100 centimeters, we can use that as a conversion factor and get 0.25 meters. Plugging all of our values into the formula is going to give us 0.201483 cubic meters. Since we were asked to round to the nearest tenth, we get an answer of 0.2 cubic meters. This concludes the TEAS Math Review. We hope that this has been helpful for you. If you need further assistance, please email us at asc@daytonastate.edu or seek us out in the Academic Sports Center on your closest Daytona State College campus. Good luck taking the TEAS.